Hello, my name is Dr. Cale Stoley. Welcome to Manufacturing and Prototyping. This is our first lecture that we're going to be covering the basics of manufacturing principles. So the goal of this lecture is just to kind of get your feet wet on topics we're going to be covering throughout the semester. Now, what I wanted to start out with is, let's give a little bit of a definition of what is prototyping and what is manufacturing. So when we talk about prototyping, well, prototyping has many different views. There's actually lots of different types of prototypes. You can have models, you can have scale prototypes, you can have functional prototypes, but the overarching goal of prototyping in general is when you go to build a prototype, what you're doing is you are trying to understand the full behavior of how a concept works. Okay, and that concept may be realized into a full product. It may be realized into a near complete item, but it's mostly just for research purposes and as an assistance in the development process. So it is realization in some capacity, the realized version of a model for research purposes. Okay, and the goal of developing a prototype is, can you take a prototype and can you turn around and use that prototype to better understand what you would make for a final product? Okay, prototyping in manufacturing is it's integral, it's necessary. As we move through this semester, we're going to be discussing different types of prototypes, and you will be developing different types of prototypes. But now what we mean by manufacturing in the scope of this class is manufacturing is the process of, man, this is a squeaky marker, developing saleable products for consumption. Okay, now consumption can mean many things. It can mean use, it can actually mean consumption, but manufacturing is the process of making a product, converting it into a saleable entity, and then basically getting it ready to be consumed, be used by some consumer somewhere. So this is what we're going to be dealing with in this course. We're going to be talking a lot about prototyping and manufacturing. Now, what we're going to lead off this conversation with today is what is the current state of manufacturing? And of course, I don't have markers that are wanting to work with me. So when you talk about the current state of manufacturing, manufacturing has changed dramatically within the last 20 years. Over the past 40 years, it has changed dramatically with the inclusion of computing. Over the past 20 years, it has changed dramatically with the advent of the internet. Over the past 100 years, innovations in mechanical engineering, innovations in many different styles of manufacturing have lent us to a new environment. Today's manufacturing world is different from what it was 30 years ago. We're using different types of principles. Lean Six Sigma manufacturing, lean manufacturing is a common term that many manufacturers are moving toward. And it's a guiding principle that you don't manufacture what there isn't an immediate demand for. When you have a process streamlined to the point where if somebody requests a product and you can provide that product within a day's time, usually that is an acceptable delay. And if you can provide a fully product from development to completion within a day, then you manufacture based off of the demand rather than creating a surplus in hopes that someone will purchase your surplus. It's a different way of thinking. It has changed manufacturing dramatically, and let's dive into that a little bit. So the concept of lean manufacturing is, this is a very big topic in a lot of manufacturing facilities today. Now, the concept isn't new, but it's gained a lot of traction as companies continue to see benefits to lean manufacturing and continue to see methods of being able to employ lean manufacturing in their own work. So lean manufacturing, again, the idea is produce to demand. You manufacture what people request from you. Larger manufacturers that have lower volume sales are moving towards more lean manufacturing, because if somebody says, I would like an ATV, well, if you already have an ATV built and you've already got it at the manufacturing firm, you can just ship it straight out the door, and that's great. But if you're waiting 4 weeks from the time when somebody says, well, I want an ATV, and you've got this ATV sitting on your lot, well, it may mean that you've produced 5 or 6 other ATVs that are now in the way. So when you go to get that ATV out and try to ship it, now you have to reorganize your inventory so that you can remove that one component. And you may select the wrong one, ship it, have to ship it back. It creates a potential for error. And this is where a lot of Six Sigma principles come in, is because you want to reduce error. You want to reduce the costs of those errors to the company. Sending the wrong product, you may be shipping 1,000 miles. Well, to ship it 1,000 miles, have it come back, and then have to ship another one, that's a very costly error. You may be talking thousands of dollars just because you picked the wrong component. So how do we streamline our processes so that we aren't producing too much that it's going to waste, or potentially we have a product change by the time we actually go to sell something, so we're not selling outdated materials, and so that we're not selling errant materials. These are principles that are very, very common in today's manufacturing. We're going to get into more of these later on this semester. But this has brought about a brand new style of manufacturing. And I will go ahead and say it's brand new because it works today with what we have for modern technology. So all of the influences we've had on modern technology today, let's go ahead and put that in. We have cutting edge research. This may be into algorithms, such as machine learning algorithms have changed. Even within the last 5 years, there's been major advances. We've had material advances. Lots of research is being done in many aspects of our known world, and we're slowly integrating them into the manufacturing environment. But that's only one of the influences on the current state. We have the internet. Okay, the internet allows for communication at a very rapid pace. It allows for exchange of information, and it also allows for cloud-based things. It allows for a lot more automated systems, and so where you could be monitoring a system that is miles away from you, and it's not that challenging. You have, and this is here, it's kind of related to some of the cutting edge research, you have vision systems. In today's world, we have the ability to mount cameras and have those cameras be put into algorithms whereby we can detect objects, we can make things safer for people, we can make things easier for robots to do. This has enabled a substantial amount of things in today's world, and it's continuing to influence the way we do markets. You have innovations in robotics. Okay, these aren't just how robots move, but it's now we're seeing a rise in collaborative robots. We're seeing a rise in the types of activities that robots use. Research into robotic grippers enables robots to do things that they weren't able to do before, like pick up a loaf of bread, which can be very challenging because you don't want to smash the bread, but you also don't want to fill it full of pinholes, and you don't want to grab it incorrectly so that it gets ripped apart in an industrial environment. We've had to adjust our robotics to handle a lot of different materials. We're now dealing with robots that can pick up very fragile items to robots that can pick up giant rubbery items. And they take two very different kinds of robots. We're dealing with robots that are at a very large scale, to now you'll have robots that can fit on a tabletop where somebody can be working at a desk while a robot is sitting next to them assembling things. We've just seen major shift in the robotics market, and collaborative robots have kind of stormed in, the idea that you'll have a robot that's working next to a human. And the price of robots as a whole has gone down in recent years, which furthermore makes them more accessible in the manufacturing environment. Okay. Aside from robotics, we have seen a number of advances just in the state of knowledge. Okay. We know more than we used to know. And we can also rely on mistakes that were made in the past. We understand different types of manufacturing methods. We understand how things can be done differently. With the spread of the internet, we now have a broader set of knowledge that we can rely on when we make decisions. Okay? And above and beyond just having the knowledge and having that experience and that background, we can say that one of the bigger influences in the modern manufacturing environment is that we have seen advancements in the modern manufacturing environment. Ironically, this is a self-feeding service. So we have seen cell phones, we have seen advancements in microscopic microchips, nano innovation. The cutting edge research has fueled a lot into technology, and this has allowed us to have more streamlined processes. We have better software now. We have better manufacturing equipment. And these are things that weren't available 20 years ago, but they are available today. And all of these have had a major influence in our current state of manufacturing. Okay, so as we address all of these individual topics, there are a few other influencers here that are shifting the conversation on manufacturing. And I feel like those require a little bit more in-depth discussion. One of the big topics in today's world is the idea of sustainability and eco-friendliness. Here, we consider our consumption and we consider our waste. Okay, how are we consuming in a way that is sustainable? When we manufacture something, is it requiring deforestation? Is it requiring the removal of a rare species of rubber plant? Is it requiring something that's more that's not going to be obtainable in 100 years? Are we making things out of coal and gasoline? If our processes require that, we know there's a finite end to every one of those. So as we look at our consumption, and we look at all the products that are being consumed, how can we take our consumption and plan for the future? How can we use materials that are regenerating? How can we use materials that are going to be available to us indefinitely? But it also brings into conversation a lot of ethics. When you produce a product, say it may be sustainable itself, but the process of obtaining that item may cause great damage. You may have seen some about the lithium mining that's happening down in South America. There are ethical concerns with lithium mining, and the more we use lithium products, the more those ethical concerns are going to come to the front. So how can we consume in a way that is ethical? But on the other side of it, what happens to our waste? Now, this isn't just industrial waste. The byproducts of painting, byproducts of machining, those, yes, they have to be considered. We have to have appropriate disposal. A lot of those follow very well-written standards for how do you rid yourself of metallic waste? How do you rid yourself of chemical wastes? Those industrial wastes, those standards are written, those codes are written to protect environments from machinery, from these companies. And yes, every company is going to have to deal with them. And the government will continue to identify areas where that is a potential hazard, and they will continue to create more codes and standards by which the industrial environment has to abide by. And that is definitely something that is shifting the state of manufacturing. But aside from just industrial waste, what about product lifespan? What happens to your product when it reaches the end of its life? How is it being reused? How is it being recycled? Is it a throwaway product? If it's a throwaway product, how is this product going to behave in a landfill? How is this product going to behave in the backyard if you leave it out exposed to sunlight for indefinite amounts of time? So this is something that is affecting our modern manufacturing environment, and it's a topic that we all need to be discussing. As engineers, as management, we need to be talking about how are we consuming in an ethical way, but how are we also producing waste in an ethical way that is considerate of the individuals around us. Okay. Aside from sustainability, we've also seen in recent years some very, very rapid advancements in a type of manufacturing called additive manufacturing. Okay, 3D printing. Most everybody wants one. Even the people who don't know how to use them, they want the one because it's hot technology. You can do a lot with it. I've seen many chessboards made out of 3D printed pieces. It's very interesting. But now, how can we take this in a manufacturing environment? Well, additive manufacturing as a whole bridges the gap between model and prototype. We now have the ability to directly come up with a physical prototype of a model that is virtual, so we can take something from the virtual environment and produce it in the real environment just by clicking a button. Now, it's not always made out of the right materials, it may require some additional work to get through, but additive manufacturing has revolutionized our way of prototyping. Now, one of the things that we're looking at moving into the future is as additive manufacturing continues to increase in speed, is this going to affect manufacturing as a whole? If I need, I've seen this example thrown about. If I need a tooth implant as a dentist, because I've got a patient who has a bad tooth, I get the form of the tooth, you can cast it in place using materials you already have. You can go through that process. You can ship it off to another place that will make it, coat it, ensure the safety of it, bring it back, and actually put it inside of the person. All of those are great. But if you could take a 3D model of that tooth, 3D print it using advanced materials, and install it right there, it would simplify the process, it would better use the time of the dentist and the technicians in that office, and it would make the process a lot less cumbersome. You're not dealing with somebody who's creating your tooth, who's hundreds of miles away. Your tooth is being made right next to you, and you have the ability to monitor that process. You understand what materials are going into that tooth. Now, we're not quite there because, first of all, the speed of manufacturing is there, and we're still working on different types of materials that can be used. But we live in that type of manufacturing environment where now this is a known potential possibility. We could be headed in this direction. So we all have our eyes on additive manufacturing and how that's going to be used in the future. Additionally, we have all started looking at automation. COVID-19 has brought about a major discussion in the area of automation because we're seeing massive job shortages. We're also seeing a lot of individuals who are no longer trained to do these positions. In the state of Nebraska, the job market for a technician is really scarce. You have a group of people who are vying for a much, much larger group of positions. And what you end up with is you will oftentimes hire somebody who's not very qualified simply because you need someone that much. Technicians are in such high demand. Engineers are oftentimes called to take a step down and work a technician's role while also being an engineer, just to try to bridge that gap and fill in a basic fundamental need of many of these companies. Automation assists with that. Using robotics, using robotic systems, using intelligent pathways and design, we can eliminate the need for those technician positions that are so poorly filled, and instead we can replace those empty positions with robots. There was a lot of discussion when I was in college myself about the ethics of automation, because automation is removing job positions. Well, the problem in today's world is that those job positions are open. And now, yes, there are still individuals who are required to manage those automated processes, and there are still a very high demand for technicians, but the fact that we don't have individuals to fill those positions has really fueled automation significantly. We're looking at more automated systems, and robot costs have gone down. Vision system costs are going down. People are understanding this technology better. We're seeing it implemented into certain systems. You have companies like Amazon that have created fully automated robots that go out and do part picking. And they will put parts in a bin, and then that bin will be put in a place where it can be shipped to someone. This is what we're seeing as the future of automation. Now, automation also has a number of added benefits that go along with it. With automation, one of the issues that you'll see is that technician level positions tend to be the ones who get hurt the most. They're bending over constantly, they're lifting heavy loads, they may be involved in eye strain, trying to have to capture information. Automation works with these individuals to reduce the severity of some of the tasks that they have to do by carrying things for them, by identifying information and making it in a much more easily accessible route, by streamlining information. Okay? This is all due to automation. It is making the workplace safer, and it is also making the workplace more productive and cheaper at the same time. A safer environment is a cheaper work environment in the end. Less lawsuits and all of that. And please don't ever work for a company that disagrees with that statement. just gonna go ahead and throw that out there. Be a part of that culture. Advocate for safety. Always advocate for safety. You can't put a price on the life of a human. So these are some of the topics in today's world that are affecting the conversations about manufacturing, where companies are taking a risk on buying a new robot because they know automation is coming. They're taking a risk on buying a 3D printer because they know additive manufacturing is coming. They're taking a risk on purchasing items that are going to reduce their waste output, ponds that will help them digest inorganic materials and produce much less toxic substances. I've seen some of that. And you've also seen just companies who have invested in different types of material research to develop materials that they do feel more ethically inclined towards. So this is, again, just a very high-level discussion on manufacturing, where we're at right now, where we've come from, and where we're going. We don't always know where we're going, but we do know what's in the works right now. So we'll talk about some of these topics more. Oh yeah, and of course then the lean manufacturing and Six Sigma, which we talked about at the very beginning. But we'll talk more about these topics in depth throughout this semester. And as we get closer to the end of the semester, you're going to be employing some of these